Hi and welcome back. As you can see, I'm not in my study today. I'm outside, out in the backyard of my house. Such a nice day, I thought I'd come out here. Let's see how this take goes. The last take was going really well, and then my dog decided to ruin it by barking, so we'll see how we go with this one. The reason I thought I'd bring it outside today is because we're talking about volume and capacity, and we're doing some stuff with water. Didn't really want to do it in my study, so I thought I'd bring it outside. We're doing a thing today called volume displacement. Volume displacement is when we're trying to measure how much space an object takes up, and the way we're going to do it is by putting an object inside the water. So what you need to do is you need to fill up a container of water, a measuring cup. This one is filled all the way up to, well, that's pretty bad. It's just above 250, I think. Okay. And what we're going to measure is when we put objects inside of our measuring cup, we can measure the initial volume of the water, which would be 500 mils, and then we put our object in the water and we see how much the water level goes up. And then if we subtract the fact that it went up to 800, and we do 800 take away 500, which I initially started with, we can see that this object here must weigh 300 milliliters. Now there's something really cool in maths, which is going to be hard because I'm going to try and turn around really awkwardly. Okay, that 1 milliliter equals 1 centimeter cubed. So that 300 milliliter answer there could also be 300 centimeters cubed. Keep that in mind. Milliliters equals centimeters cubed. It doesn't equal mass. It's not about mass because you can have really light objects that take up a lot. It equals volume. So 1 milliliter equals 1 centimeter cubed. So let's do an example right now. Like I said before, my initial container should not have worked here. Anyway, this is very hard. 250 milliliters, all right? Now we're going to take our pick between Daddy Pig, a rock that my kids found at a walk, or a tin of baked beans. Ooh, which one should I pick? Let's go tin of baked beans. Before we start, I reckon you know what, you've already tried this before. Picture there's a bath and you're trying to get into the bath, and when you get in the bath, the water level goes up. That's what we're talking about. The volume of you going in the water makes the water level rise. I don't know if you've ever had that before where lots of people, like there's two people in a bath and they both get out at the same time, the water level drops down dramatically. That doesn't mean there's less water. You're not in it, so your volume is being taken out. So this started at 250. I put in this, and I can see here that it is gone up to 400 milliliters. I'm not lying. It probably is going to blur me out. I'm sorry about that. 400 milliliters. So if it started at 250 and now it's at 400, I can spill water all over the table. This is why it's an outside activity. 400 take away 250. 400 take away 250 means that the volume of this can of baked beans is 150 milliliters. Or, if they equal the same thing, 150 centimeters cubed. Now I'm going to refill this water to make sure it's the right way now. So it says now, you know what? I can't really tell. Let's just keep it going for now. Okay, still at 250. Still at 250. This time I'm going to put Daddy Pig in. All right, Daddy Pig gets up to, could be Grandpa Pig, I have no idea. About 300. Okay, so it's about 300. So I would then use the new one, which is 300, and I would take away what it started with at the start, which is 250, and that will leave me with 50 left. So the answer would be 50 milliliters, or 50 centimeters cubed. Okay. The last, you didn't say that, did you? No. The last one, all right, the last one's a rock. Put that in there, start at 250. This one goes up to about 350. So if it started at 250 and it's gone up to 350, 350 take away 250 would leave me with 100 left, 100 milliliters, 100 centimeters cubed. Now, I'm not going to make you do this at home because I don't want to get in trouble for making you make a mess all over your house. But what we're going to do is I'm going to show you some pictures of what the containers initially looked like and then what they look like after an object's been put in them. And you have to subtract the new volume, take away the old volume to find how much each of the objects weighed after they were put in. Okay? I hope that's been helpful. I hope the cars and the trucks and everyone going past hasn't made this video really difficult. I know I'm probably not going to be out here again. This turning circle is not very good for me and I seem to have made a mess. But I hope it's been a little bit of a change of scenery for you guys and I hope you've enjoyed it. Thanks for watching.